Using casting. Why do we need to use casting? Using typecasting, it is possible to recover a heading member. As I said that we may need to use casting if we need to access the methods or fields that have been overshadowed by our objects. For example, if we are using in this, as we have been doing in this case, we are declaring an object with the superclass reference, then we may not be able to access any method in this subclass, that is the derived class, but if and that is shadowed by this the type of the object that we are using. Because of that, we cannot access the methods of this subclass. Now, to avoid those situations, we might need to use casting. Using typecasting, it is possible to recover a hidden member, class variable, class method, or an instance variable, but not an overridden method, an instance method. An overridden method can be recovered only by means of a supercall and derived class. We have seen that previously, that how we can access the overridden method. If we are using method overriding and we have the same methods and a superclass and a subclass, and if you want to access a method and of the superclass, then you can use the access that by using the super call, and the super call is by using the super keyword super dot and the name of the method. For example, we have these two classes, class base 2 with the variable integer x initialized to a value. Then we have a class that derives the base 2 class with the exact same variable. The name of the two variables is exactly the same, but the values are different. Now, if you want to see which variable will be printed and which variable will be shadowed, we can use this example, and we can see that, for example, this object is initialized with the subclass reference, this object is initialized with the superclass reference, and in this case the value 10 will be shadowed when we use the subclass reference object, and the value of the subclass will be printed. But this is the value is hidden, and in the second case the value of, or if you want to access the value of the superclass, then we can convert it into the object of the superclass, and we can access the value of the superclass. So we can see that how values or methods can be hidden when we use inheritance or polymorphism, and if we try to access those values, then we can use casting for this purpose. There are certain rules that can be followed. For example, at compile time, checking is carried out to determine whether the cast type and the type of the existing reference variable are related through inheritance. So in classes we can only in objects we can only do casting among classes that are related through inheritance. At runtime, a check is made to determine whether the object actually pointed to is compatible with the cast type. And at runtime, it is made sure that if what we are converting is exactly compatible with the class that we are converting into. So, for example, we have this hierarchy as shown in this graph, and we have declared these objects. Student S1 is an object of this class, that is a subclass of the student class. Now S2 is an object of the tertiary student class. Employee, that is a subclass of the person class, but is in no direct relationship with any of these other classes. And then we have declared an object of the employee class. Then we have objects of these other classes as well. So if you want to see how are they compatible with each other, so now this object is compatible compile time compatibility, and this is runtime compatibility of the object, and these should work. If we try to convert this object into tertiary student object, this should perfectly work. And same should be the case with this one, because it is already as of type tertiary student, then this conversion is already there. There is no compatibility between the tertiary student class and the employee class, so it should not be allowed by the compiler. It will not be allowed by the compiler if we try to convert the object of the employee class to an object of the tertiary student class. If we try to convert the object of, for example, S3 is an object of the college student class with the superclass reference. If we try to convert this, it should be okay at the compile time. If we try to convert this object to the tertiary student object, then it should be okay at compile time, but at runtime it will get us a compatibility. It will get us a compatibility error. S4 in this case, let's say S4 is an object of the superclass of the tertiary student, and if you try to convert the superclass object to the subclass object, then we might get this through the compiler, but at runtime we might not be able to get through with this. If we will get an error. And S2, that is a superclass of this tertiary student class, this should be okay. We can do it through direct assignment as well. An object of the subclass is already an object of the superclass, then they should work fine even without this explicit conversion. We can directly assign S2 to an object of the student class. So for the sake of compatibility, we need to understand these rules whenever we are trying to cast one object to another object. So to summarize, the things that we need to keep in mind: what object conversion does, make it possible to reference an object in a different way by assigning it to an object reference of a different type. So that is usually done when we are doing widening conversion, where we can automatically assign an object of one class into an object of another class. It is handled automatically by the compiler. So in this case, for example, if we are assigning an object of the subclass to an object of the superclass for some reason, then that should work fine without any error. The object is not converted or changed in any way. We need to keep this in mind, that even though when we assign an object of one class to an object of another class, the object in itself remains the same. It is not like our primitive data types. When we, for example, assign a value to a variable and then we replace it with another value, the value of the variable changes. This is not the case with the objects. Once instantiated, an object never changes its type. A cat will always be a cat. The concept is similar to the widening conversion performed on primitive data types. So when we convert to an wider value, the value of that variable remains the same. Now for casting, it is needed when the compiler doesn't recognize an automatic conversion. For example, when this assignment is not allowed or is not recognized by the compiler, then we need to explicitly do type casting. If you remember downcasting, we are converting an object of the superclass into an object of the subclass. That is the case over here. The concept is similar to the casting of primitive data types to perform a narrowing conversion. That is something that we do explicitly. Again, casting, like conversion, does not change the reference of the object being pointed to. It only changes the compiler's treatment of the reference. Casting is only legal between objects in the same inheritance hierarchy. We need to keep this in mind that we can only convert or cast between objects that are related through direct hierarchy or inheritance relationship. You can safely cast from an object of to its superclass. So casting does not change the reference, and we need to keep this in mind. It might be an important concept to remember, that even though when we cast an object of one class to an object of the another class, that might allow the object to maybe access some additional data that are in the subclass, for example. but it does not change the value of the object. The object remains the same, but its referencing gets wider in this case and referencing gets narrower in this case. The value of the object never changes. You can go through this exercise and try to find out the solution for this, and you can write your solutions or your answers in the comments. This is another example. Maybe you can go through it, run it, and try to find the solution for it. Now, to understand the difference between overriding, hiding, and overloading methods, an instance method in a subclass with the same signature, name plus the number of and the type of its parameters and return type as an instance method in the superclass overrides the superclass's methods. We have seen this, that whenever we override a method, then there is a method in the superclass that is exactly with the same signature implemented in the subclass, and that is method overriding. If a subclass defines a class method with the same signature as a class method in the superclass, the method in the subclass hides the one in the superclass. By this we mean that when we, for example, declare an object of the subclass and we call the method, even though an object of the subclass is an object of the superclass, we will be getting the results for the method of the subclass. The method of the subclass hides the method of the superclass in this case, and that is what we saw with the variables as well. The variables of the subclass hide the variables of the superclass, and when we need to call the variables of the superclass explicitly, we need to use the super keyword. The distinction between hiding and overriding has important implication. The version of the overridden method that gets invoked is the one in the subclass. So when we use call the method, the subclass method will be called. The version of the hidden method that gets invoked depends on whether it is invoked from the superclass or the subclass. So we can invoke the superclass method or the hidden method by using a call to the superclass method. Overloaded methods are differentiated by the number and the type of the arguments passed into the method. Overloading is, on the other hand, for example, if we change the number of parameters, then that is method overloading. The compiler does not consider return type when differentiating methods, so you cannot declare two methods in the same class with the same signature, even if they have a different return type. The return type is not part of the signature of the method, so we cannot have a method with the same signature with different return types in a class. Then there are some example exercises. You can go through these exercises and try to find out a solution if there is any, or try to find out a problem if there is any. You can go through all of these exercises and try to find your solution and try to post your answer either in the Piazza page or in the comments on the KCMS. Go through these exercises one by one, and if there is any problem, we can discuss those problems in our next lecture. This will conclude our lecture of static and dynamic binding and casting. We will continue our discussion of exceptions in our next lecture.